So units and measurements. Okay, before we talk about what units and measurements are, let us start by discussing the concept physical quantities. Physical quantities. Mind you, these quantities are what makes us measure or dimension a particular concept. Do you understand? So we cannot just dimension or measure anything. We must measure quantities. Is that okay? And these quantities must be physical. Do you understand? You can't dimension what you can't see. You can't measure what you can't see. So you must see these things before you'll be able to dimension them or give accurate measurements to them. And that is why this course is called physics. Do you understand? Because it relates to our everyday activities. Now I can see some other participants. I can see, okay, like I said, Lucky or Zero. I can see Tecno Spark 3 Pro. I can see Infinix Smart 3. I would like you to change the name to what I can relate with. So I will not just call you Tecno Spark 3 Pro or Infinix Smart 3. Okay? Now, once again, I am Akada and I will be your tutor for this class, the introductory physics. Okay, all right. I can see Dana. She has changed her visibility or her name to Dana. So you're welcome, Dana, and I'm happy and super excited to have you on this platform. Okay, now I haven't said what physical quantities are. We would now move forward to what units are. Okay, unit is actually that particular thing. See, I'll make sure the explanation is so lame, do you understand, or lay to anybody, such that if you pick it up, you can understand. So don't worry. Is that okay? So I'll be using some terms that you'll be like, what's this guy saying? But don't worry, it's just for you to understand the concept better. Do you get it? That is why we are here for you. So units helps us to differentiate physical quantities. Is that okay? Units helps us to differentiate physical quantities. Just like in a class, we can have 5 different Victors, like students bearing Victor. We have Victor, 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 and Victor. You can also have so many, in fact, we have in this world thousands of people with the name Success. Is that okay? But what will make me differentiate one Victor from the other or one Success from the other is actually the surname or other names, such that a student can be called Victor Moses, while the other can be called Victor Elijah. Do you understand? So the unit is that particular thing that helps us to differentiate between one physical quantity and the other. For instance, if I say length, if I say the length of my phone is, it is just an example. Is that okay? So don't crucify me. Is 0.5 meters. Okay? 0.5 meters. Don't crucify me. This is not realistic. Is that okay? It's just an example. Now, this is my phone, which is 0.5 meters. Right? It is a physical quantity. It is a phone. Do you get it? So if I say that same phone, probably another person's phone, is 5.2, let's say 5.2 centimeters. Okay? Now, you realize that this unit differentiates my phone from the other phone. Though they talk about the same thing, which is the length, but this unit is different from this other unit. That is, centimeter is different from meters. Of course, we can convert both of them to the same unit. Do you understand? So later on, I'll make you understand how we can convert a unit to another unit. Do you understand? So this is just a layman example. For instance, if I have force 10 Newton, this one will be clearer. If I have force 10 Newton and I have mass 5 kilogram, of course, kilogram and Newton are two different things. Is that okay? Force 10 Newton and 5 kilogram. Kilogram shows the weight or the stuff that that particular object is made of. Do you understand? So this particular unit helps us to differentiate the physical quantity mass from the derived quantity. Of course, force is a derived quantity. It is a quantity. Do you understand? Insofar as it is a quantity, be it derived or fundamental. Do you understand? Later on, I'll tell you what fundamental quantities are and what derived quantities are. Do you understand? This is just like an overview of what unit is. And of course, measurements of physical quantities involves the comparison of some quantities precisely based on the defined value of that particular quantity. So if I say, in a simpler term, if I say I want to cook rice for my brother, okay? I want to cook rice for my brother. The measurement of that particular rice will tell me, or the number of people that will consume that rice will tell me the measurement I would use. For instance, if it were to be for my brother alone, probably the maximum quantity it would take would be 2 cups. Do you understand? So I would measure, or I would cook it based on that particular measurement, which is 2 cups. Do you understand? So we measure physical quantities differently. I'm sure you understand what that is all about. Now, having said that, let us define some quantities. Now, the quantities in the whole universe, is that okay, can be divided into 2 basic quantities, 2 quantities rather. The first one is the fundamental quantities and the derived quantities. Fundamental quantities and the derived quantities. These are the 2 major quantities that we have, at least for your level. Is that okay? We have fundamental quantities and derived quantities. What then is the fundamental quantities? Of course, from the name fundamental, it means that these are the basis. These are the basis. Is that okay? They are the bedrock upon which other quantities are built. So without these fundamental quantities, we cannot have the other types of quantities that we are going to talk about later. And the 3 basic fundamental quantities that we have are the mass, length, and time. So the fundamental quantities are divided into 3 basic quantities, which are the mass, the length, and the time. What then is mass? Of course, from the definition of what matter is any substance whatsoever that has mass and occupies a space. Most times we interchange the word mass with weight. Weight and mass are not the same thing. At least for your level, you should know that. And if you don't know that, know it for sure now that mass and weight are two different things. Is that okay? Now, the mass of a particular substance tells us the content of that substance. So if I have this pen, as you're seeing on your screen, this pen is made up of little stuffs. Now, combined together to form this particular pen. Is that understood? So the stuffs that make up this pen tells you the mass of the pen. And we can measure this mass with so many things. We can use beam balance, we can use weighing balance, and so on and so forth to measure the particular stuff that an object or a substance is made of. Is that okay? And the measurements or the things we use to measure the content or the stuffs a particular object or substance is made of depends on that particular substance. Do you understand? Like in your kitchen, you can use a scale to measure a particular stuff. Do you get it? So that is what mass is. But weight is a force. Is a force that attracts any object whatsoever to the center of the mass or in the center of the earth. And this force is being exerted on the object by the earth itself. Do you understand? So the force in which the earth exerts on an object to attract it to the center of itself is called the mass. It's called the weight, rather. So having defined or differentiated what weight is and what mass is, I would like you to know that the mass of an object is measured in kilogram, though other units of measurements are equivalent to kilogram, but the standard unit, some scientists and mathematicians and so on and so forth came together and sat on on this concept and said, no, there should be a generally acceptable unit or system of units of measurements that would be accepted worldwide. So if you're in Nigeria and you pick a particular object and you say this object is 10 kilogram, if you go to Australia and measure that same object, it should give you the same quantity because we have a generally acceptable system of measurement. Is that okay? And that generally acceptable system of measurement is called the SI system. Do you understand? So the SI system or units for mass is the kilogram. Like I said, we have other corresponding units like the milligram, like the gram, okay, the milligram, we have the kilogram, and so on and so forth. Do you understand? So the length shows the differences between two distances, or the difference between two distances. Do you understand? So if I have the length of a particular ruler to be 100 centimeters, it shows that the interval between the starting point to the finish point of that particular ruler is 100 centimeters. Do you understand? Okay, so, but the SI unit for the length of a particular object is in meters. The SI unit is the standard units for the length is meters, while the time shows the duration. It shows when a particular thing starts or an event or anything. Like this class was scheduled for 7 p.m. Is that okay? So the time is 7 p.m. and it should last for about 45 minutes. So the difference between the interval of our starting point to our ending point is 45 minutes. And we have the standard units for measurement of our time, which is in seconds. Is that okay? Which is in seconds. All right, having said that, I would like to move further to what the derived quantities are. So, if fundamental quantities are the basis upon which other quantities are formed, then upon which the units for other quantities are formed, then the derived quantities are those quantities that are formed by the fundamental quantities. That is, in a simpler term, derived quantities are dependent on the fundamental quantities. In mathematics, we have dependent variable and independent variable. Okay, so let's call the fundamental quantities the independent variable because they don't depend on any other thing to have what they have. Do you understand? To become what they are. Do you get it? They are just like that. While the derived quantities need other quantities to be able to stand, and that is why they are dependent on the fundamental quantities. Okay, so an example of the derived quantity is volume. Volume. You realize that volume is the combination of some quantities to form it. So let's say from what volume is, we say volume is the product of the length of an object times the breadth of an object times the height of an object. Of course, volume cannot stand alone because we have three quantities, three things that helps us to give the exact description of what the volume is. Do you understand? So, having said that, we have that length measures distance, breadth measures distance, and height measures distance. That shows us what the volume of a particular object is. And volume is said to be a derived quantity based on these conditions. You can think of other derived quantity. We have surface tension, we have viscosity, and so on and so forth. So these are derived quantity, and I'm sure you know why they are called the derived quantity. Of course, it is because they cannot stand on their own. Do you understand? They can't stand on their own and be called a quantity. Their units are formed from other fundamental quantities, from the combination of all the other fundamental quantities. Okay, so having said that, I would like us to discuss the concept dimension. Dimension. If you're close to a contractor, probably your dad or your mom is an engineer, I'm sure you'll be familiar with the word dimension. Okay, the dimension of this room is 12 by 10, is 15 by 15. Do you understand? It shows, okay, the distance between this point to this point, from this point to this point to this point and to this point is, let's say, 12 by 15 meters. Do you understand? So dimension actually shows how quantities are related to the fundamental quantities mass, length, and time. Dimensions, I'll come again, shows how other quantities are related to the fundamental quantity of mass, length, and time. So having said that, we are going to take a look at the applications of dimensional analysis. But before we talk about application of dimensional analysis, of course, you can apply what you don't know. So dimensional analysis is what helps us to adequately relate physical quantities together. From the word, we know what dimension is. Dimension shows us how these physical quantities are related. Is that okay? So analysis shows us the bit by bit or the stepwise approach to relating these quantities. Do you understand? So having understood what dimensional analysis is, then we can go over to the applications of dimensional analysis. As the class is going on, if you have questions, okay, I can't see any question for now, but if you have questions, you can drop them, or if you feel like dropping the questions at the end of the class, no problem, because there would definitely be a question and answer section after the class. Now, the application of dimensional analysis. So we've discussed dimensional analysis. Okay, so let us look at the applications. The first application is that it helps us to verify or to know how correct, is that okay? How correct a physical equation is. Dimensional analysis helps us to verify or know how correct a physical equation is. For instance, we've been in situations where in an examination hall, you just forgot the equation of motion, the first equation of motion. Of course, you know that the first equation is, V equals AT minus U. Another equation comes to your mind. V equals U plus AT. Another equation, no, it's not AT, it's AT squared. But you don't really know which one is. Okay, you can decide to pick one of them. Yes, probably you have enough time. Of course, in our Nigerian system, most examination times are not enough for us. So that is why you have to be exact, accurate, and fast to pass any examination. Okay, let's say you eventually decide to check if this equation V equals U plus AT is correct or not. Okay, now it is dimensional analysis that you use to check if this equation is correct or not. Is that okay? So that's the first application of dimensional analysis. Now let's check how we can use dimensional analysis to check the correctness of this particular equation. The first thing you have to note is that V is velocity, because without knowing what each term is, then you can't analyze it. Okay, so this is the velocity. This is also velocity. A stands for acceleration and T stands for time. So what differentiates V from U is that V is the final velocity and U is the initial velocity. Okay, so the final velocity, initial velocity, A is the acceleration and T is the time. Okay, now I want to check how correct or exact this equation is. Okay, what is the unit for velocity? Of course, the unit for velocity is, before discussing what unit for velocity is, we need to know what velocity is, right? So it is the ratio of the distance covered over the time, right? So we have distance over time. Okay, now equals initial velocity is also velocity, so it is also distance over time. And acceleration, of course, is the ratio of the velocity covered by a particular, the velocity of a body to the time. Is the ratio of the velocity of a body to the time. So we have velocity over time. And because time is here already, so we'll multiply it by the time. Do you understand? So, of course, time cancels time. So we are left with distance over time you're left with the distance over time, which is equal to distance over time, plus velocity on its own is distance over time. Of course, distance over time, distance over time, distance over time are the same. Therefore, since on the right hand side, so you have to compare the right hand side and the left hand side. So since the right hand side is equal to the left hand side and we have two quantities in the right hand side, so we are just going to pick them as one since they are the same. Do you understand? So we have distance over time equals distance over time. So by definition, they are correct. But by dimensional analysis, distance has a dimension. Is that okay? Time also has a dimension. Do you understand? So what is the dimension for distance? Now we have to relate. Remember, we said dimensioning of a physical quantity relates or helps us to relate the physical quantity to the fundamental quantity of mass, length, and time. Do you understand? So what is the equivalent of distance in the fundamental quantity? Of course, it is length. Is that okay? So distance, length measures distance, or distance measures length, whichever way you want to put it. Do you understand? But distance is a measure of the length of a particular substance. Do you understand? So now what is the dimension for distance, which is also the same thing as dimension for length? Of course, like I said earlier, mass, length, and time. So let me clearly state these. So mass, the dimension for mass is capital letter M. Is that okay? And the unit is kg. The dimension for length is L. And the unit is meters. Okay? The dimension for time is T. And the unit is seconds. So, it is not SEC. It is simply S. Okay? So, we have MLT. How do we relate MLT to distance over time? Of course, we have that the distance, which is a measure of the length, is L over T, which is also equal to L over T. So we have used dimensional analysis to show that the equation V equals U plus AT is actually correct. So just for the sake of knowledge, check if this particular equation is dimensionally correct or not. And the equation is V square, let's still use equation of motion. V square equals AT square minus U. So check if you can use dimensional analysis to confirm the exactness of this particular equation. So that is the first application of dimensional analysis. Another application is that we use dimensional analysis to derive the units of a physical quantity. So derivation of units. Derivation of units. Now, to derive this, to check, let us still use the same equation of motion that we used earlier. So we have V equals U plus AT. Okay? Now we said this is distance over time equals distance over time plus distance over time. So from these, we can get the units of each of these. Is that okay? The units for velocity, which is distance over time, what is the units for length? Let me show you. The unit for length is m from what we have here. Okay? Is m. While units for mass is kg. And the units for the time is seconds. Okay? So if we bring or relate it to what we have here, we'll have that distance over time, of course, is m over s. Okay? This is also m over s. And dimensionally, this gave us m over s. Okay? So we can say that the units for velocity is meters per second. And some people are comfortable writing it as meters per second. Okay? Now let us check for acceleration. Acceleration is velocity over time. And what is the unit for velocity? We know that it is meters over seconds. And time, this sign is also there, divided by, okay? So divided by time, which is also seconds. So if you do your normal arithmetic, you have that this is m over s divided by s. So we have m over s times, if you take the inverse of s, it will give us the division sign would automatically change to multiplication. So we have 1 over s. Therefore, the unit for acceleration becomes meters over second squared, or meters per second squared, or meters per second squared. Okay? So that is the unit for acceleration. So the last thing we use dimensional analysis to verify is we use it to derive the exact form of relationship of a particular quantity or group of quantities. Okay? But for the scope of this class, I will extend this particular application to the next class. So this is what we're going to start with before we delve into what we have for the next class. Okay? So we use dimensional analysis to derive the exact form of relationship between physical quantities. Okay? Between physical quantities. So we'll begin with this application in our next class. So we'll just do like a general overview or a recap of what we dealt with in this class in the next class. So if there is any question, let me check if you have questions. Okay, there is no question for me. Of course, I'd also assume you understand everything that is being said in the class. So in our next class, we'll start with the application, the third application of the dimensional analysis, and then move to what we have for the fresh class. So see you in the next class. Please make sure you invite people to the platform. Tell them about what is going on here, because if they don't know, they can't be a part of it. I'm sure you enjoyed the class, and I enjoyed the class because this class is not complete without you. So see you in our next class.